Myself Prakash P. Today we have to see a simulation of dynamics laboratory, that is DOM, under the experiment name TYPE FLYWHEEL. Before going to that, you should know what is the virtual lab. Visit the website vlab.co.in. Virtual lab is an initiative of MHRD under the National Mission on Education through ICT. You can scroll that, you can see broad areas of virtual labs. Choose your specific domain. My domain mechanical engineering. Click the mechanical engineering. You can see the list of labs under mechanical engineering, and then select dynamics of machine lab. You can, first of all, you should know what is my dynamics of machine and what is the main objective of this lab. Dynamics of machine is nothing but to study the motion, system motion based on the force acting on it. Under this experiment, which helps to enhance the student knowledge on force analysis in a dynamic system and improving the understanding of inertial effects which are acting on them. This lab covers the 4 subjects like kinematics of machine, dynamics of machine, robotics, and vehicle dynamics. In left side, you can see the introduction, list of experiment, target audience, course alignment, and then feedback. You have to select the list of experiment. You can see the list of experiment. There are 9 experiments are done. You have to click the TYPE FLYWHEEL. In left side, you have see the aim, and then theory, and then pre-test and procedure, simulation, post-test, reference, and then feedback. First of all, you should know what is the objective of this experiment. We have to calculate the moment of inertia by varying the radius of TYPE flywheel and varying the mass. We have to calculate the moment of inertia and comparing the moment of inertia, both theoretical and experimental values. This is the main objective of this TYPE flywheel. You have to click theory, some introduction and theory, and what are the formulas we are using to calculate the moment of inertia is there. First of all, you should know what is the objective of TYPE flywheel. You should know the structure of TYPE flywheel, and second one, we have to calculate the time taken to reach the metal bar on ground by varying the size of the radius of the flywheel and mass. With the help of angular acceleration equation and equation of motion, we have to calculate the time. And third one is analyze the time required when the metal bar reaches the ground, comparing both rim type and disc type flywheel. Final one is comparing the application of rim type flywheel over disc type flywheel. This is the main objective of flywheel. First of all, you should know what is my flywheel. Flywheel is nothing but it is an energy storage device. Whenever the requirement of energy is needed for that system, flywheel will supply the energy to that system. This is the main function of the flywheel. What are the formulas we have used for calculating moment of inertia by experimental and theoretical value? For theoretical value, we have to calculate the moment of inertia, that is I equal to mr square, where m is the mass of the flywheel and r be the radius of the flywheel. By directly substituting the mass and radius, we have to calculate the theoretical value of moment of inertia. For calculating experiment, we have used the conservation of energy equation. Based on that equation, we have to derive that how we calculate the moment of inertia by experimentally. That is I equal to 2 m into 2 gh by omega square minus r square divided by 1 n plus 1 n2, where small m indicates the mass of the metal bob and g is the acceleration due to gravity, that is 9.81. H is the height, capital H is the height, and that height indicates the gap between the ground and metal bob. V is the velocity, omega is the angular velocity, F is the frictional energy lost per unit rotation, N1 is the number of rotation completed by the flywheel, and N2 the number of rotation made by the flywheel after spring has left the axial. This is the formula we have to calculate experimentally. You can see that diagram. This is the rim type structure flywheel. This is the 3-dimensional picture of the rim type flywheel. And next, you have to click the procedure how to do that experiment. By clicking the procedure, there are certain steps we have to follow. Next, we have go to simulation part. Click that simulation. What are the procedures we have seen that step we have to follow in that simulation part. You can see that simulation part. This is the front and side view of the flywheel. A metal bar which is attached of mass m with the help of string. These are the 2 variables. One is the radius of the flywheel and m is the mass of the metal mob. You can adjust the radius of the flywheel. You can increase the flywheel. The size automatically will increases. Similarly, you can increase the mass. The mass of the metal bob also increases. You have to set that value, radius of the flywheel and mass. Next you have to click under control button, you have to click play button. The flywheel start rotate. The mass of the metal ball will fall to the ground. The flywheel does not stop immediately. It takes time to rest. That is, it takes some time to stop that flywheel. You can see that M 19.361 that is the mass of the flywheel. Next one is the R. Next one is the time taken to reach the ground developed in that experiment. We calculate the theoretical moment of inertia and the experimental moment of inertia. How we calculate means by in theoretical moment of inertia we have a formula I equal to capital M capital R square. Capital M is the mass of the flywheel 19.361 and capital R is the value already we have seen. We have entered 12 and that is the radius of the flywheel, which is in centimeter. We have to convert into meter, that is 0.12 meter. I equal to capital M capital R square. We have to multiply 19.361 into 0.012 square. You get the value of the value and enter that value in that box 2.278 by calculating. This is the theoretical moment of inertia. By experimental moment of inertia we have to use that formula, that is I equal to small m into 2gh divided by omega square minus r square divided by 1 plus n1 by n2, where small m that is 0.2. Next one 2 g is nothing but the acceleration due to gravity, that is 9.81, and capital H is the height. There is a distance between the initially there is a distance between the metal bob and ground, which indicates the capital H height, that is the 2 meter. You have to substitute that value in capital H divided by omega square. You can see that value, that is 4.76 radian per second, minus r square. R value is nothing but 0.01898 meter divided by 1 plus n1 by n2. N1 is the 17 revolution, n2 is the 92.076 revolution. You can substitute that value. Is I equal to m 2gh by omega square minus r square divided by 1 plus n1 by n2. You can get that value is around 0.29. You have to enter that value in that box and click submit. You can see that result. There is the comparison between the theoretical moment of inertia and the experimental moment of inertia. This is there is a 0% error, which is nothing but your calculation is correct. Suppose you have your value is suppose instead of 0.29 you get 3, means you have to enter 3 and click submit. That is the percentage of error. You can see that experimental moment of inertia, that is there is some part of value you have choose it as wrong calculation. You can redo that calculation and check the calculation once again and get the corrected value. This is the comparison between the theoretical moment of inertia and the experimental moment of inertia. Once your answer is right, the percentage error is 0. You have some answer is wrong. You have see that the experimental moment of inertia answer is 0.2 net, but we receive 0.3. This is the percentage error, 0.344 percentage. So we have to redo that calculation and correct the value. Similarly, what the students can done to I am doing that radius for 12 and mass of m. You can increase the radius of the flywheel. That is you have to convert that radius into 13 or 14 or 15. Similarly, you have to increase the mass of the metal bar and you have to calculate the value, that is with the help of formula. For theoretical moment of inertia, I equal to capital M R square. We can directly calculate the theoretical moment of inertia. For experimental moment of inertia, we have to use that formula. Already we have seen I equal to m 2gh by omega square minus r square divided by 1 plus n1 by n2, and then substitute all the value in that formula and get the result, and whatever the result you obtain, and you have to submit that, enter the value in the theoretical moment of inertia and experimental moment of inertia, and then click submit. You have to check whether the answer is correct or not. You can see that result, that is the theoretical moment of inertia and experimental moment of inertia. Suppose the value is wrong, how much amount, that is a percentage error it comes. You can redo the calculation and correct the value and submit it.